So next topic is we will talk about spherical polar coordinate system. So coordinates are r, theta, phi. Any general vector A can be written as AR r cap, A theta theta cap, A phi phi cap. So we have three mutually perpendicular axes x, y, z, and P is any general point P, and this point P lies on the surface of a sphere. In spherical symmetry, point P lies on surface of a sphere. Point P lies on surface of a sphere. Where r is the radius of that sphere, r is the radius of the sphere. R is the radius of the sphere. Theta is this angle. Theta is angle made by radius vector with z-axis. This is the radius vector which makes an angle theta with z-axis. And this arrow shows the positive direction of theta. Arrow shows the positive direction of theta. And what will be angle phi? Now let's draw perpendicular on z-axis. So this angle is 90 degree. And in this triangle, projection of r along z is r cos theta. And in perpendicular direction, projection is r sin theta. Now let's draw a parallelogram. This is parallel to z-axis and this line is parallel to r sin theta. Now you will get this plane. This plane makes an angle phi with x-axis. And this arrow shows the positive direction of phi. And this plane contains r cos theta and r sin theta. So what is phi? Phi is angle made by plane which plane containing r cos theta and r sin theta with x-axis. That is the angle phi. So we have specified what is r, what is theta, and what is phi. Now see what will be possible limits of, let us first show the unit vectors. What will be direction of unit vector? By definition, r cap, theta cap, phi cap, they are in the increasing direction of their coordinates. So increasing direction of r, so this direction is positive r cap. Now increasing direction of theta is, theta cap is perpendicular to r cap. Theta cap is perpendicular to r cap in the increasing direction of theta, because if point P moves in this direction, theta is increasing. So that's why this is positive theta. Negative theta is opposite to this. Negative r is opposite to this. Clear? So this is the positive theta. If point P moves in theta cap direction, theta is increasing. And what will be phi? Phi is perpendicular to this plane in the increasing direction of phi. Phi cap is perpendicular to this plane, because if plane moves in the phi cap direction, then phi will increase. And r cap, theta cap, phi cap, they are perpendicular to each other. R cap, theta cap, phi cap, they are perpendicular to each other, just like x cap, y cap, z cap. They are perpendicular to each other, just like all are perpendicular to each other, just like x cap, y cap, z cap. They all are perpendicular to each other. R cap, theta cap, phi cap, they are perpendicular to each other, just like x cap, y cap, z cap. Let's further visualize it. So let us assume I am considering this is z direction, this is x direction, and I am taking this perpendicular direction as y direction. This direction I am taking as y direction. So you can say this board plane is xz plane and this direction is y. So if you have any point P, what will be its coordinates? Coordinate, and this point is the origin. So coordinate of point P is r theta phi. Coordinate of point P is r theta phi. This is the origin, this is z axis. So from origin to point P, just connect with radius r and draw a sphere of radius r, where center is at the origin, r is its radius, and what will be angle theta? This radius vector, this is the radius vector which makes an angle theta with z axis. Clear? Now take projection of r along z. So this is r cos theta, and this projection is, or this is r sin theta. So r cos theta and r sin theta, they will make this plane that I have drawn here, and that plane makes an angle phi with x axis. This is x axis. So this plane makes an angle phi with x axis. This is angle phi. Yes or no? This angle is phi. So this is r, this is theta, and this angle is phi. Now what will be r cap? Increasing direction of r, because in this direction r is increasing. What is theta? Perpendicular to r cap, because if P moves in theta cap, theta is increasing. Clear? So this direction is positive theta cap. Now what will be phi cap? Phi cap is this direction, because if plane moves in phi cap direction, phi is increasing. And now you can visualize r cap, theta cap, phi cap, they are perpendicular to each other, just like x cap, y cap, z cap. Is it clear? Now you can visualize that r cap, theta cap, that will lie in this plane, but phi cap is perpendicular to this plane. So if you see here, then you can visualize this, that r cap, theta cap, actually they lie in this plane, and phi cap is perpendicular to this direction. And if plane moves in phi cap, phi is increasing. So that is positive r cap, positive theta cap, and positive phi cap. Is it clear? So that is the symmetry of r theta phi. Now we will see what should be the angle. What are the possible angle here? In general, r can vary from 0 to infinity. You can take 0 to infinity means you can take any radius. 0 to infinity. What about theta? Theta varies from 0 to phi. What about phi? 0 to 2 pi. Phi 0 to 2 pi. But theta 0 to pi. Why theta 0 to pi? Not 0 to 2 pi? So just see the symmetry. Now definition of theta is what? Angle made by radius vector. Theta is angle made by radius vector. So that is angle between two lines. If this is z axis, this is radius vector. So this radius vector makes an angle theta with z axis. Radius may be here, radius vector. This angle is also theta. Radius is here. This angle is also theta. It means if you consider upper hemisphere, so if this radius vector may be at any point, when radius vector is along z, what will be theta? This is angle theta. When radius vector is in xy plane, pi by 2. If you rotate this in xy plane, theta is pi by 2. So in this symmetry, 0 to pi by 2, you can cover the upper hemisphere. All direction of theta. This is also theta. This is also theta. This is also theta. So you draw a cone. All angles are theta. So that is the symmetry of theta. That radius vector makes an angle theta with z axis. So that's why 0 to pi by 2 you will cover upper hemisphere. From pi by 2 to pi you will cover the lower hemisphere. Okay? That is the angle theta. But what about phi? Phi is angle made by this plane with x-axis. Angle made by plane with x-axis. So when it is parallel to xz plane, what will be phi? When it is parallel to yz plane, pi by 2. Again this pi, 3 pi by 2, 2 pi. So you have to rotate this. So you have to start with 0, pi by 2, then pi, 3 pi by 2, 2 pi. So you have to cover the whole circumference. So that's why phi varies from 0 to 2 pi. So if you want to cover the whole sphere in terms of phi, you have to vary phi 0 to 2 pi. But theta varies from 0 to pi, you can cover a sphere. Clear? Now we have to see how to relate r theta phi with x, y, z. So how you will write x? That is, you should write component of r sin theta along x axis. So that component will be cos phi. This is r sin theta cos phi. What about y? In perpendicular direction, projection is sin phi. So this is r sin theta sin phi, and z is r cos theta. Z is r cos theta. So if you know r theta phi, you know x, y, z. Or sometime if you know x, y, z, you can write r theta phi. That you can easily check. R will be given by under root x square plus y square plus z square. Theta is cos inverse z by r. And phi is tan inverse y by x. So that is r theta phi in terms of x, y, z. So that is a spherical symmetry. You know direction of unit vectors, you know how to specify r theta phi and how to write x, y, z in terms of r theta phi or r theta phi in terms of x, y, z. Again, we have to see how to write dl, dA and d tau. Same dl, infinitesimal displacement vector. In Cartesian coordinate, we have seen that dl is given by dx x cap plus dy y cap plus dz z cap, and if x y z changes by dx dy dz, then change along x cap is dx, change along y cap is dy, and change along z cap is dz. If you draw an elemental cube, so what will be change along x cap? That is dx. Change along y cap is dy. Change along z cap is dz. In same way, we can write dl in a spherical polar coordinate. So let's write the dl vector, infinitesimal displacement vector. So point P is r theta phi. You should move to point Q, r plus dr phi plus d phi. So again, dl vector you will write as we will see what will be change along r cap, what will be change along theta cap, what will be change along phi cap. Now you have to visualize the elemental cube whose axis is along r cap, theta cap, phi cap. Here axis is along x cap, y cap, z cap. So you can easily visualize that change is dx, dy, dz. Again you have to visualize the elemental cube, but now axis is along r cap, theta cap, phi cap, and you have to see what will be change along r cap, theta cap and phi cap. Clear? So let's see this figure. If r changes to dr, so simply change will be dr. You have to redraw this figure. So just redraw this. This is the origin here. This point is the origin. So if you have a some vector r here, so along r cap, what will be the change? This change is given by simply dr. You have to see change along r cap when r changes to dr. So along this axis, you can easily see that change. That will be simply dr. So that's why here you will write dr. Okay? Now see here, if theta changes to d theta, let's see, this theta changes to d theta. So what will be change in theta cap? So I am redrawing this. This is theta cap, this is r, and this is d theta. Angle is equal to arc by radius. Angle is equal to arc by radius. So radius is, arc will be simply, this arc will be r into d theta. So this change is given by r d theta. So change along r cap is dr. Change along theta cap is r d theta. Now you have to see change along phi cap. So phi cap is this direction. So if phi changes to d phi, let's say this changes d phi. So what will be this change? So let's redraw this again. This is phi cap. This is r sine theta. This will be d phi. So again arc will be r sine theta into d phi. So this is r sine theta into d phi. So this is dl vector. This is dl vector in spherical polar coordinate. So must remember dl in spherical polar coordinate. dr r cap, r d theta theta cap, r sine theta d phi phi cap. ठीक है? And just like here, dx, dy, dz are sides of the elemental cube. So in spherical symmetry, axis is r cap, theta cap, phi cap, and what will be sides of the elemental cube? dr, r d theta, r sine theta, d phi. And if you multiply those sides, you will get volume element. So now volume element is given by volume element d tau is dr into r d theta so this will be given by r square sin theta dr d theta and d phi. R square sin theta dr d theta d phi. In Cartesian coordinate, d tau is dx dy dz. But here it will be r square sin theta dr d theta and d phi. So you know dl vector and volume element in spherical polar coordinate system. ठीक है? Now we will see how to write area element. So first you should remember the dl vector. dl is dr r cap r d theta theta cap plus r sin theta d phi phi cap. This is dr r d theta. So first example is you have a solid sphere. We have a solid sphere. It's a sphere of radius capital R. It's a sphere of radius capital R. So let us first specify what will be r theta phi here. R varies from 0 to capital R. Theta varies from 0 to pi. And phi varies from 0 to 2 pi. Because it's a sphere. And this volume is surrounded by how many surfaces? One surface. So this volume is surrounded by one surface, and that surface is R is equal to R surface. And what will be direction? Away from the surface. And in spherical symmetry, this direction is R cap. So you are on the surface of a sphere. So what will be dA at R is equal to capital R? So when R is fixed, variable is theta and phi here, because R is fixed. So variable is theta and phi. So you have to multiply these two sides in area element. So one will be R d theta, another will be R sin theta d phi, and direction will be R cap. So dA is R square sin theta d theta d phi. This is dA over the surface of a sphere. ठीक है? So second example is, let's say if you have a hemisphere. Solid hemisphere, yes. This is X, this is Y, and this is Z. And its radius is capital R. So first specify R theta phi. So R can vary from 0 to R. Theta will vary from 0 to pi by 2, and phi will vary from 0 to 2 pi. Pi again 0 to 2 pi, but theta vary from 0 to pi by 2 up to xy plane. Now this volume is surrounded by how many surfaces? Two surfaces. Surface 1 is R is equal to R surface. This is R is equal to R surface. So surface 1 is R is equal to R surface, and you know how to write dA vector, that I have already written. R square sin theta d theta d phi. Now you have a surface 2 in xy plane. This is surface 2. So what is fixed for second surface in xy plane? In terms of r theta phi? Theta. So this is theta is pi by 2. In spherical symmetry, xy plane is theta pi by 2 plane. And what will be direction? Away from the surface. Away from the surface. This direction is what? Theta cap. This direction is theta cap. You can see here, if point P is in XY plane, so theta cap is downward. So downward direction is theta cap direction. So that's why this direction is theta cap. Theta is fixed. So what will be dA for surface 2? This is theta pi by 2. Theta pi by 2. So when theta is fixed, variable is r and phi. So you will get here dr into r sine pi by 2 d phi, and direction is theta. So dA is given by r dr d phi. So this is dA on XY plane. ठीक है? Hemisphere. So these are all part of a sphere. When you have a sphere or part of a sphere, you can specify r theta phi, and you can write on different surface what will be area element. Then you have, next is 1/8 part of this sphere, octant. So this is the 1/8 part of the sphere. This is part of the sphere. This is an octant. Hemisphere is half part, but you have taken again 4 part of the hemisphere, and you have taken only 1 part. So that is an octant. So this volume is surrounded by how many surface? 4 surface. Surface 1 is, this is r is equal to r surface. You are on the surface of a sphere. So this direction is r cap. Surface 2 is theta pi by 2. This direction is theta cap. So we have already discussed surface 1 and 2, r is equal to r. In same way you can write theta pi by 2. So you can easily see what will be D. Now this is surrounded by YZ plane. On this side YZ plane, on this side XZ plane. So for YZ plane, Y is fixed. What is fixed? Let's say surface 3, phi is pi by 2. YZ plane means what? YZ plane makes an angle pi by 2 with x-axis. If you have, this is x, this is z, and this is y. So this is YZ plane. So YZ plane makes an angle pi by 2. So that's why this plane is, third surface is, YZ plane is phi pi by 2 plane. This is phi pi by 2 plane. This is phi pi by 2 plane. And on phi, when phi is fixed, variable is r and theta. So you have to multiply these two sides. dA is r dr d theta. And this direction is away from the surface. So that direction is phi. So this direction is phi k. Now four surfaces, phi is equal to 0, and this direction is, yes, minus phi k. So dA is minus r dr d theta. And in this particular case, you can see r varies from 0 to r, theta varies from, what will be theta? 0 to pi by 2. And what about phi? 0 to pi by 2. So again, it's a part of sphere. So you can specify r theta phi, and on each surface you can write the area limit. ठीक है? Exact surface. This is a spherical part, then lower xy plane that is surrounded by yz plane, and then xz plane. So when it is xz plane, angle will be phi away from the surface. If this direction is plus phi cap, so away from the surface is minus phi cap. Now one last case is, fourth is the part of a sphere. Let's consider a cone. Consider a conical surface. And that cone is derived from a sphere. Let's consider this cone. This is z axis, and I am taking this angle to be 30 degree. Let's draw this cone. So cone is this particular cone is a part of sphere. Z axis, this is x, this is y, this angle is 30 degree, this radius is. Now first specify r theta phi. Let us specify r theta phi. So in this case, r can vary from 0 to r. Theta can vary from pi by 6, 30 degree. Theta can vary from this point to this point only. And what about phi? 0, phi is still from 0 to, yes, solid sphere. So that is the r theta phi. Now this volume is surrounded by how many surface? Two surface. Surface 1 is R is equal to R surface. So what will be area element? So that you can directly write R is square sin theta d theta d phi r cap. Now second surface is this surface. This is the second surface. So what is fixed? Theta is pi by 6. On the conical surface, theta is fixed because 30 degree. So when theta is fixed, what will be variable? R and phi. So dA is given by dr into r sine pi by 6 d phi, and what will be direction? Theta cap. This direction will be theta cap. So dA on this surface is, and sine 30 is 1 by 2. So r by 2 dr d phi, and direction is so whenever you have a sphere or any part of the sphere, you can specify r theta phi, and on different surface you can also write the area element. And you can visualize the symmetry how we will write r theta phi in different case. Okay? So that is all about spherical symmetry. Now we will see how to write dot product and cross product of unit vectors. Just see dot product and cross product of unit vectors. Because they are perpendicular, so you can easily write dot product and cross product of dot product and cross product of unit vectors. So let us first write in Cartesian coordinate. What is x dot x? Because angle is 0. So z dot z is 1. What is x dot y? Y dot z and z dot x? This will be 0. What will be x cap cross x cap? Y cap cross y cap? Z cap cross z cap? This will be 0. Now what will be x cap cross y cap? Y cap cross z cap? Write down this. So for cross product, you can use right hand rule. So x cap cross y cap, z cap, y cap cross z cap, x cap, z cross x cap is y cap. So this is z cap, this will be x cap, and z cap cross x cap is y cap. If you take y cap cross x cap, you will get minus sign. So you can remember this. If you move in anti-clockwise direction, this is right hand rule. you will get positive sign. But if you move in opposite direction, you have to take negative sign. In same way, you can write dot product and cross product of r cap, theta cap and phi cap. So in same way you can write, so r dot r is theta dot theta is phi dot phi. This will be and phi dot r will be theta. Then r cap cross r cap is equal to theta cap cross theta cap, and that will be phi cap cross phi cap is 0. And again you can use the right hand rule, r cap theta cap r cap cross theta cap is phi cap so r cross theta is phi, theta cross phi is r cap, and phi cap cross r cap is theta cap. So this is right hand rule for r cap, theta cap and phi cap. So now we will talk about cylindrical coordinate system. Cylindrical coordinate system. So we will represent its coordinates by r, phi, z. So any vector A can be represented as ARR cap, A phi cap, and AZ z. This is vector A in cylindrical coordinate system. So let us represent this symmetry. You have XYZ axis, mutually perpendicular axis, and there is a point P whose coordinates are R phi Z. And point P lies on the surface of cylinder. P lies on the surface of cylinder. Where R is the radius of the cylinder. Phi is this angle made by this plane with x-axis. This is also radius R, same radius R, and Z is along the cylindrical axis. Point P lies on surface of cylinder where R is the radius of the cylinder, and this plane which contains radius vector R makes an angle phi with x-axis. So phi has same symmetry as in spherical polar coordinate, and z is the cylindrical axis. So here point P r phi z lies on the surface of cylinder. Lies on the surface of cylinder, where r is the radius of the cylinder, radius of the cylinder. Phi is angle made by plane that containing radius r with x-axis, and z is the cylindrical axis. Cylindrical axis. So that is the coordinates r phi z. Now if you see limits of r phi z, r can vary from 0 to infinity. You can take any radius. Phi will vary from 0 to 2 pi, and z will vary from minus infinity to plus infinity. This z varies from minus infinity to plus infinity. Now we have to see what will be direction of unit vectors r cap, phi cap and z cap. So r cap is increasing direction of r. So in a cylindrical, this is radially outward direction. If you have a cylinder, so r cap is radially outward. So this will be r cap. Phi cap is again same symmetry, perpendicular to this plane, and z cap is this direction. So at point P, this is r cap, phi cap and z cap, and they are perpendicular to each other. They are perpendicular to each other. Now we have to relate r phi z with x y z. So what will be x here? Just see. This is r. This makes an angle phi. So what will be projection along x-axis? R cos phi. Yes. So this is r cos phi. In perpendicular direction, projection is r sin phi. Y is perpendicular to x-axis. If projection is cos phi, in this direction projection is sin phi. And z is written as sin z. Now if you have to write r here, r will be under root x square plus y square. Phi is tan inverse y by x, and z is sin. So we have specified what is r phi z, what will be direction of unit vector, what will be the possible limits of r phi z, and how to write x y z in terms of r phi z and or R phi z in terms of x, y, z. Clear? Again, in this symmetry also, if you have to calculate line integral, you must know what is dl vector. How you will write the area element and how you will write the volume element. You must know dl, dA and d tau in cylindrical coordinate system also. So what is dl? dl we have defined as infinitesimal displacement vector. Infinitesimal displacement vector. So if point P, whose coordinates are r phi z, and if there is a elemental change in r phi z, and that change is given by dr phi by d phi and z by dz. So if you want to write dl, you have to see what will be change along r cap, what will be change along phi cap, and what is change along z cap. So here you can easily see, if this is r cap, so change will be, I am taking this to be, this is r and this is r cap. So change will be simply dr. Change along r cap will be dr. So here you have to write dr. Now if phi changes to d phi, so let's say if this is r, phi changes to d phi, this is phi cap, and this changes d phi. So what will be this change? R d phi. Angle is equal to arc by radius. So this arc will be simply r into d phi. So this will be given by r d phi. And change along z cap is simply dz. Along this, you can see in z cap direction, this change will be simply dz. So this will be dl vector in cylindrical coordinate. So in these three coordinate system, you must remember dl vector. And if you know dl, you can write d tau as well as area element on different surface. So you can visualize this as an elemental cube whose axis is along r cap, phi cap and z cap. And lengths are dr along this, r d phi along this and dz along this. So what will be volume element? Just multiply the side of the cube, elemental cube. So volume element is d tau, and this d tau will be given by multiply these sides, dr r into d phi into dz. So this is d tau, I am writing r dr d phi and dz. This will be the volume element. This will be the volume element, r dr d phi and dz. Just multiply these sides, you will get the volume element. Now we have to see how to write area element on different surface. So we have to write area element. Area element dA you have to write. And you know what is dl vector? So I am again writing here. This is dr r cap rd phi cap plus dz z. So first example is, consider, let's take first example. It's a cylinder of radius r and length L. Let's consider so this is x, this will be y, and this will be z. This radius is r and this length is L. It's a closed surface. It's a solid cylinder of radius r, length L. It's a volume. And this volume is surrounded by how many surface? 3 surface. One surface is, let's say, this is z is equal to L. This is z is equal to 0. So I am writing this surface as surface 1. This is surface 2. Let's take it as a surface 2. And this is surface 3 is what? On the surface of cylinder, this is r is equal to r surface. This is z is equal to L. So if you draw some elemental area, direction will be z cap. If you draw elemental area here over this surface, away from the surface, so this direction is minus z cap. Away from the surface, this direction is r cap. I have shown the direction of area element on each surface, away from the surface. And limits you can specify, r can vary from 0 to infinity, then phi 0 to 2 pi, and z 0 to capital R. Yes, this is 0 to, in this case, radius is 0 to R, phi 0 to pi, and z 0 to L, because this is the origin here. With respect to origin, you have to specify z. So z varies from 0 to L. Now what will be for surface 1? What will be dA? Surface 1 is z is equal to L surface. So dA is given by, on this surface variable is r and phi. Variable is r and phi. So that will give you r dr d phi, and direction will be z cap. So this will be dA. On second surface, z is equal to 0. So dA is given by, this will be minus r dr d phi z cap. Minus r dr d phi z cap. And surface 3 is r is equal to r surface. You are on the surface of cylinder. When you are on the surface of cylinder, r is fixed. Variable is phi and z. So here dA is given by r d phi dz and direction is r cap. So this is first case. Let's see another case, second case here. This is same cylinder, but that is centered at the origin. Let's consider same cylinder of radius r, but this is centered at the its this is x, y. This is centered at the origin. X, Y, Z. Radius is r, length is l. Now origin is at this point. This is the origin. Here origin is here. This will be the origin. So you have to specify. Again, this is surrounded by three surface. So now surface 1 is what? Z is equal to what? L by 2. This is now we have with respect to origin you have to see. So this is L by 2. Area element will be same. Direction is Z cap. This is surface 2 is what? Z is equal to minus L by 2. And if you see the area element, direction is minus Z cap. Surface 3 is same. R is equal to R surface. And this direction is R cap. So in this case, R varies from 0 to R, phi varies from 0 to 2 pi, but Z varies from minus L by 2 to plus L by 2. Z varies from minus L by 2 to plus L by 2. So area element, same you can write. This will be if you are writing for this case. So this will be for Z L by 2. This will be for Z is equal to minus L by 2. And this will be for Z is R is equal to. This is for R is equal to R. So in this case also area element will be same. Only you call it as L by 2 and this is minus L by 2. Now third example I am taking as a, let's call it as a quarter cylinder. Quarter cylinder. This is X, Y and Z, and let's consider this radius is R and this length is L. It's a quarter cylinder. It's a quarter cylinder. 1/4 part of the cylinder. You have taken 1/4 part and one part you have taken. This is 1/4 part. So that's a quarter cylinder. Now this volume is surrounded by how many surface? 5 surface. So this is surface 1 is Z is equal to L surface. And what will be area element over this? Z cap. Then you have surface 2 is this surface. This will be Z is equal to 0. So direction is minus Z cap. Surface 3 is R is equal to R. So this direction is R cap. Now surface 4 is phi pi by 2, because that is, this side is YZ plane. YZ plane is phi pi by 2 plane. So direction will be, this direction will be plus phi cap. And surface 5th is phi is equal to 0. Away from the surface, this direction is minus phi cap. So this volume is surrounded by 5 surfaces. It's a part of cylinder. So if you specify R phi Z, phi will be 0 to pi by 2 and Z will be 0 to, this is R phi Z. And dA again you can write on these 3 surfaces, this will be same. Z is equal to L. What will be dA? This is R dr d phi and R dr d phi, R dr d phi Z cap. 2 is Z is equal to 0, that is minus R dr d phi Z cap. And third is R is equal to R. So that will be given by R d phi dz R cap. So these 3 are same. Now surface 4 is phi pi by 2. So when phi is fixed, variable is R and Z. So on this surface, this is given by dr, dz and phi cap. Fifth is phi is equal to 0. So dA is given by minus dr dz. So this is the area element. So if you have cylinder or any part of the cylinder, you can specify R phi Z and you can also write their area element on different surface. Okay. Now you can write dot product and cross product of unit vector. Dot product and cross product of unit vector. So what will be, in same way you can write R dot R, phi dot phi and Z dot Z is 1 r dot phi dot z, and z dot r is 0. Then you will get r cap cross r cap is phi cap cross phi cap, and that is z cap cross z cap is 0. And for right hand rule, again you can remember, if you move in anti-clockwise direction, so this is r cap, this is phi cap, and this will be z cap. So r cap cross phi cap, this will be z cap. Phi cap cross z cap is r cap, and z cap cross r cap is phi cap. So this is the right hand rule for cross product of these vectors. So if you move in anti-clockwise direction, you will get positive sign, and if you move in clockwise direction, you will get negative sign. Okay? So that is all about cylindrical coordinate system. Now, one another point is there. Let's define the vector triple product. Vector triple product. So first is scalar triple product. If you have three vectors, so you know that cross product is a vector. Let's say B and C are two vectors. If you take cross product, so that will be a vector. So you can again take a dot product with that vector. So that will give you scalar triple product. And if you take cross product, that will give you vector triple product. So you must remember this. So this is given by, this is A, and this will be same. And for calculation purpose, in component form, you can write, you have to use this determinant value, and here you have to write AX, AY, and AZ. This is BX, BY, and BZ, and this will give you CX, CY, and CZ. This is CAB, yes, ABC. This is A dot B cross C, same as B dot A cross C, that is C dot A cross B. You have to remember this point. So this A dot B cross C, you will get this particular scalar value. This is a scalar value. And you will see geometrically mod A dot B cross C represents volume of a parallelepiped generated by A, B and A, B and C. Simplest example is a cube. Let's say if B and C forms the base and A forms the its height or altitude, so that will be its volume is given by A dot B cross C. Even if they are tilted at some angle, for example, let's say if you have this vector and there is another vector A here, let's say this is B vector, this is C vector and this is A vector. So you will get the volume of this parallelepiped generated by ABC. Simplest case is the cube. Simplest case is the cube. So that is a scalar triple product. Similarly, you can also find vector triple product. Vector triple product. So because B cross C is a vector quantity, so you can take again a curl. So this is A cross B cross C and that will be a vector quantity, and this will be given by B A dot C minus C A dot B. You can remember this as a back cab rule. Back cab. So A cross B cross C, you can remember as a back cab rule. This will be B A dot C minus C A dot B. So that is vector triple product. You can use this formula. ABC, ABC, BCA, BCA and CAB. Yes, this will be CAB. ABC, BCA and CAB. Yes, this corrected. This is ABC and this will be BCA. Please correct it. And this will be CAB. All values will give you same scalar.